Hi there, everybody. I'd like to walk through projecting rasters again. Just as a reminder, the USGS data, the NED data, comes in a geographic coordinate system. And if we look at the properties, you can see here that the cell size is very small. That's because the units on these are in degrees. And if we scroll down to the spatial reference and take a look at the assigned coordinate system for this data, you can see that it is in a geographic coordinate system and it has angular units of degrees. There isn't a linear unit associated with this. If we look at the extent of the data, that should be clear here. These values are all small. They're less than 180. So these are angles basically in the degrees of the angles, which means these are the north, south, east, west extent of this data as defined by latitude and longitude, and these are the angles of the numeric values of the angles of latitude and longitude. So if you were to assume that this was a projected coordinate system, this data would plot up very small. ARC would be treating these as meters instead of degrees and would be plotting these up, this whole data, the extent of the data would be within, just tens of meters of itself, when in fact it covers an enormous chunk of Utah. So this is kind of how you need to read the raster information, is look at the cell size, ask yourself if that makes sense. If it's a very small number, chances are it's in degrees. You can scroll down to the extent and verify that this is a geographic coordinate system, and then you back it up here. Now it does have linear units for the vertical coordinate system. That just means that meters are the units for the elevation values. Here, that's typical. That doesn't mean that. But the vertical coordinate system is defined in linear units of meters. Elevation is almost always provided in meters, unless somebody has run a raster calculator on the data set and changed it to feet. Okay, so that is that. And now to run the Project Raster tool, the thing to be hyper aware of here is the resampling method. So you input your information here just as always. It's going to default put in the input coordinate system is going to be defined for you. It'll pull it from the properties. You need to define the output coordinate system here. The resampling technique is very important. The default is nearest, and if you read the tool help, let me expand this a little bit and bring this back. Oh, come on. There we go. You will see nearest, which is the default, shouldn't be used for continuous data. It's something that you should use for land cover or soil type. Data that has had a discrete boundary in some way, or is a categorical cell value. Something, like a name of a soil type, but with any kind of continuous data like elevation, slope, wind speed, solar radiation, all of those things, you're going to want to use either bilinear or cubic. And the difference between these is that so the bilinear will result in values that are constrained by your minimum and maximum. The cubic convolution, you can end up with values that exceed your min and max, and so I would probably recommend using bilinear interpolation for your resampling technique, but you need to ignore the fact that this says optional. It is absolutely not optional. If you run it with nearest, you can do that for an experiment. You'll get kind of a gridded striping pattern that you can't do away with, and it's really quite ugly and can mess up your terrain analyses. I've seen some really funky results with running the watershed tool on a DEM that was resampled using nearest neighbor, and it created all these weird little bubble pockets within watersheds, and it was kind of a fun detective story, try and figure out where that had come from. So not optional, continuous data, bilinear, and then you can set your X and Y. I sometimes will clean these up if I'm working with something close to a 10-meter DEM, just pop 10 in there just so that it's a nice round number. Okay, that's it. So if you're having issues with heavy shadowing on your hillshade working with data from the USGS, it's because it comes in a geographic coordinate system. What you need to do is run Project Raster bilinear interpolation on the DEM itself, and then go and run the hillshade again, and I think you'll find that you get some really nice results. All right, that's it. Questions, let me know. Thanks.